Hello and welcome to Cannon County High School Algebra 2. Today is another in our series of videos designed to help those of you trying to bring your grade up to passing for third quarter. And today we're going to look at how do I do BB.3. So Mr. Lyon, I think you still need to sit over there. Won't be long and you get to take that mask off. That's good. Let's take a look at BB3. I'm just going to bring the computer over here and let's take a look at what they're asking us to find. You're definitely going to need a calculator for this one, so turn on your cell phone and get the Calculate 84 app out because we're going to want to use that. It says we are going to be evaluating explicit formulas for sequences, which sounds complicated, but really that just means we're going to be plugging numbers into a function to find the terms of a sequence. So for this one, it says, find the first four terms of the sequence defined below, where n represents the position of a term in the sequence. Start with n equals 1. That just means we're going to start out with 1, plug it into this expression right here, and that will go here. And then we'll go to 2, and we'll plug a 2 in and put it right there. And then we'll do a 3 and plug it in, and so on. And then we'll do 4, and that's it. So they want us to find the first four terms of this sequence. So let's do that. What is 3 to the first power? It's 3. So 3 times 3 is 9. The first term in this sequence must be 9. Let's go to the next one. What is 3 to the second power? Well, 3 times 3 to the second power, and if you want to, you can use your calculator for this. Let's just take 3 times 3 raised to the second power. We hit enter, and it says that the answer is 27. So I'm going to put in 27 right there. Now you do the same thing, but now you plug in a 3, right? We plugged in a 1, we plugged in a 2, now we're going to plug in a 3. So we want to type in 3 times 3 to the third power. So 3 times 3 raised to the third power, that gives us 81. So in this blank, we're going to put an 81. And for the last one, we're going to do 3 times 3 to the fourth power. 3 times 3 raised to the fourth power, and we get 243. 243. So you can see on each one of these, they're going to ask you to find the terms of a sequence, and you start with whatever number they tell you to start with, and you just plug them into the expression that they give you. Okay? Let's jump up a level and see if these can get more difficult. Okay, well, let's try this one. That doesn't look any more difficult, but it does look different. Find the first four terms of the sequence defined below, where n represents the position of a term in the sequence. Start with n equals 1. So just like before, we're going to plug in a 1, then we're going to plug in a 2, a 3, and a 4 into this expression. So first, what's negative 2 times 1 minus 1? Negative 2 times 1 minus 1. It's negative 3. So the very first blank, we're putting a negative 3. All right, now we go to the next number, 2. Negative 2 times 2 minus 1. Negative 2 times 2 minus 1. And we get negative 5. Negative 5. And you keep going. Now we plug in the 3. Negative 2 times 3 minus 1. Now I know you can probably do this on in your head rather. But just to make sure, negative 7. Now at this point you might be thinking, well, I think I know what the next one is without even calculating it. This looks like an arithmetic sequence, and it looks like the common difference is negative 2. They're subtracting 2 each time, and you're absolutely right. So let's just not even bother calculating that last one, and let's just put in negative 9 because we know where this is going. Okay? Let's see. Let's jump up one more level and see if we can find some difficult problems. All right, we're already up to 81, so if you can do a one where it's on 81, you can certainly get up to 80. This one says, Find the 53rd term in the sequence described below. Well, that sounds different. Where n represents the position of the term in the sequence. Well, that just means if they only want us to find one term, but they're telling us which term it is. It's the 53rd term. So what do you suppose we're going to plug in for n? That's right, 53. So let's give that one a try. Let's see, negative 72 times 53 minus 89. So you just plug in the 53 into the function, and we get negative 3,905. Negative 3,905. And that's it. So there you go. That is BB3, evaluating explicit formulas for sequences. I hope this helps. If you have any questions, just put them in the comments below, and I will talk to you soon. Thanks. Bye.